Hello everyone, and welcome. Today we're diving into a topic that sounds a little intimidating, but is actually one of the most interesting and useful tools in all of mathematics: trigonometry. Trust me, by the end of this, you're going to see it's not so scary after all.
So, let's start with a little puzzle. Picture this. You're standing in front of something massive, like the Qutb Minar. How on earth would you figure out exactly how tall it is without climbing to the top with a measuring tape? Well, believe it or not, the answer is trigonometry, and it's actually much simpler than you might think.
You see, when you look up at the top of the tower, your line of sight, the ground, and the tower itself, they create a perfect right-angled triangle. And that is the secret of trigonometry. It gives us this incredible power to find heights and distances we can't physically measure, just by understanding the relationship between the angles and the sides of a triangle.
So here's our game plan for today. We'll start with what trigonometry actually means, then we'll get to know the sides of a triangle, which is super important. We'll meet the 6 famous ratios, solve a problem together step by step, and I'll finish up with a quick recap and some really crucial exam tips. All right, let's jump right in.
Okay, first things first. What does this big, fancy word trigonometry even mean?
Well, if you break it down, it's actually pretty simple. It comes from 3 Greek words: tri, meaning 3, gon, meaning sides, and metron, meaning measure. So it's literally the measure of 3 sides. It's all about how the angles and sides of a triangle relate to each other. And you know, this isn't just for exams. It's used everywhere, from building massive bridges to designing the graphics in your favorite video games.
All right, now before we even touch a formula, we have to learn the language of a right-angle triangle. This is a point where a lot of students get confused, so please watch this next part carefully. If you get this right, I promise, the rest of it becomes so much easier.
So take a look at this triangle. We're going to make angle A our reference point, our point of view, you could say. Now, here's the key thing. The names we give to the 3 sides all depend on where we are looking from, in this case from angle A.
First up, we have the superstar of the triangle, the hypotenuse. It's the easiest one to find because it's always the longest side, and it's always sitting directly across from the 90-degree angle. No matter what, that's the hypotenuse.
Next, let's go back to our position at angle A. If you look straight across the triangle, the side you're facing, well, we call that the opposite side. Simple as that. It's the side opposite to the angle we are looking from.
And finally, we have one side left. The side that's right next to angle A, but isn't the hypotenuse, is called the adjacent side. The word adjacent just means next to, so that's it. Hypotenuse, opposite, adjacent. Getting these 3 right is absolutely the key to everything.
Okay, and now for the main event. Let's meet the ratios. This is the real heart of trigonometry. There are 6 of them in total, but we're going to start with the 3 big ones. Think of them as your new best friends: sine, cosine, and tangent.
First up is sine, which we write as sin. The sine of an angle is simply a ratio. It's the length of the opposite side divided by the length of the hypotenuse. So for angle A, sine A equals opposite over hypotenuse.
Next, we have cosine, which we write as cos. And you guessed it, it's another ratio. This time, it's the length of the adjacent side divided by the length of the hypotenuse. So cos A is adjacent over hypotenuse.
And our third main ratio is tangent, written as tan. Tangent is the ratio of the opposite side to the adjacent side. Now, a lot of students use a simple phrase to remember these 3. SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. SOHCAHTOA. It really helps.
So what about the other 3 ratios? Well, here's the best part. If you know sine, cosine, and tangent, you already know the other 3. They are just the reciprocals, which is a fancy way of saying they are the flipped versions of the first 3. Cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. And cotangent is the reciprocal of tangent. Easy, right?
Okay, so theory is great, but we all know that math is learned by doing. So let's roll up our sleeves and walk through a typical exam question. We'll do it together, step by step. You've totally got this.
Right, here's our question. We are told that tan A is equal to 4 by 3, and our job is to find the other 5 trigonometric ratios for angle A. So where do we even begin?
Well, the first step is to use the information we have. We know that tan A is opposite over adjacent, so we can draw a triangle and label the opposite side as 4K, and the adjacent side as 3K. Now, why the k? This is a crucial exam point. The k is a constant that reminds us we're dealing with a ratio. The sides could be 4 and 3, or maybe 8 and 6, or 12 and 9. The k accounts for all of those possibilities.
Okay, so we have two sides of our triangle, but we're missing the third one, the hypotenuse. We need it for the sine and cosine ratios. So, how do we find the third side of a right-angled triangle when we know the other two? Exactly, our good old friend the Pythagoras theorem.
So let's plug in the values. The hypotenuse squared is equal to 3k squared plus 4k squared. That gives us 9k squared plus 16k squared, which adds up to a nice, neat 25k squared. We take the square root of that, and we find that our hypotenuse, AC, is 5k, a perfect 3, 4, 5 triangle.
Fantastic. That was the hardest part. Now we have all three of our sides labeled. The opposite is 4k, the adjacent is 3k, and the hypotenuse is 5k. Finding the rest of the ratios from here is going to be a piece of cake.
And here they are. We just plug our side lengths into the definitions. Sine A is opposite over hypotenuse, so that's 4k over 5k, which simplifies to 4 over 5. Cos A is adjacent over hypotenuse, which is 3k over 5k, or 3 over 5. And the other three are just the reciprocals of those. And notice how the k just cancels out in the end? That's the whole point of ratios.
Amazing work. Let's just do a super quick recap of the most important points from today. This will help lock it all into your memory.
So, to sum it all up, first, always identify your sides correctly, hypotenuse, opposite, and adjacent, based on your reference angle. Second, remember the main three ratios, SOHCAHTOA. Third, know that the other three ratios are just the reciprocals. And finally, if you're missing a side, Pythagoras is your best friend.
And I'm going to leave you with one final, very important exam tip. Please always remember to use the constant k when you set up your sides from a ratio. Just writing 4 and 3 might lose you marks. Using 4k and 3k shows your teacher that you truly understand that these are ratios, not fixed lengths. Keep practicing, and you'll be a pro at this in no time. You did a great job today.